All right, good morning. Today we're taking on solving quadratic equations. So there are four methods for solving quadratic equations. We can solve by taking the square root. Usually for that type, it's easy to isolate the quadratic term. It's easy to get the x squared part all by itself, and there's no linear term when we're trying to solve the equation. Factoring, we just have to be able to see the pattern and be able to unlock it as the product of various factors. Quadratic formula, we hit you hard with that one a lot in Algebra 1. Let me remind you of the quadratic formula. Okay, we can use it for any quadratic equation that's in the structure of ax squared plus bx plus c is all equal to 0. So we may have just the quadratic term. We may have the quadratic linear and the constant. We might have the quadratic and the constant. We might have the quadratic and the linear, combinations thereof, right? But we have to have at least the quadratic term for it to be a quadratic equation. So then the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, that quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and then the last strategy that we use, the last method that we use is a process called completing the square, and we'll hit that one at the end of this page. All right, so my instructions are solve each quadratic equation using the specified method, simplify radicals. So first up here, I have x squared equals 50. Pretty easy. The quadratic term is already isolated, so I can take the square root of each side. So here I'm going to have right now x equals plus or minus the square root of 50. Why is it plus or minus? Well, that quantity of x, right, could have started off as a positive or negative number, but when it gets squared, if I square a positive or a negative number, it's forced positive. So I have to acknowledge that that x value could have been positive or negative initially. So here I have x equals plus or minus the square root of 50, but I can simplify the square root of 50. I know that that's 25 times 2, so here's a pair of 5s. So my final answer would be plus or minus 5 square root 2. I could always write that as two separate solutions. That would be no problem. So you could give me x equals 5 times the square root of 2, x equals negative 5 square root 2. That would be fine. All right, for b here, I'm saying again, solve by taking the square root. So I'm trying to get this quadratic part right here all by itself. So the first thing that I have to do is I need to take away 5 from each side. So now I have 2/3 times x minus 1 squared is equal to 12. Okay, next I want to get rid of the 2/3. So to do that, I can multiply by its reciprocal. So the reciprocal is just flipping the fraction. So when I flip this fraction, that's 3/2. And the reason that I multiply by 3/2 is because over here, that will make this part go away to 1, reduce to 1. So now I have just x minus 1 as a quantity squared equal to. Well, I have to multiply 12 by 3/2. So I'm going to picture the 12 as over 1. And when I'm multiplying fractions, I can always simplify top down or on the diagonals. So the 12 and the 2 here can reduce to 6 and 1. So I can see that it's really 6 times 3, which is 18. So now that I have that quadratic term isolated, I can solve by taking the square root. So take the square root of each side. I now have x minus 1 equals plus or minus that square root of 18. But square root of 18 is 9 times 2, so there's a pair of 3's in here. So x minus 1 equals plus or minus 3 square root 2. And then the last thing I need to do is add the 1 to the other side. So x equals 1 plus or minus 3 times the square root of 2. Okay, and that reads as 2 solutions. If you want to write them out separately, that's not a problem. All right, next I'm saying let's solve by factoring. So if I look at the first one here, I can recognize that that's a difference of 2 squares pattern. I can see that this is 2x as a quantity squared, and this is 5 squared. And I see the subtraction sign right there. So this is a difference of 2 squares pattern. So then I can rewrite this as the product of 2x minus 5 times 2x plus 5, all equal to 0. So now I can take each factor and set it equal to 0 and solve for x. So 2x minus 5, all equal to 0. 2x plus 5, all equal to 0. So for this one on the left, I'm going to add the 5. So 2x equals 5, and then divide by 2. So I get that x equals 5 halves, 5 over 2. And then on the right, I'm going to take away the 5. So 2x equals negative 5. Divide each side by 2, and I get x equals negative 5 halves. Just like that. So I end up having opposites, plus or minus 5 halves. If you wrote them together like that, perfectly fine. All right, for b here, I see that there's a negative 1 out in front. And whenever that happens, I need to divide it out as a GCF. So let's start with that. GCF first. So divide out that negative 1. And when I divide each term by a negative 1, it switches all of the signs to their opposite. So I now have x squared plus x minus 72, all equal to 0. All right, so 0 was divided out, GCF, and I'm left with, here, this basic quadratic trinomial. Let me write that. So basic quadratic trinomial. And that's because the a value is 1. Right here, that value is 1. So what I'm looking for are 2 numbers that multiply to a negative 72 that add to 1. So if I make a little cross, my product, the a times the c, negative 72. And then the sum is the b, which is 1, negative 1. No, sorry, positive 1, positive 1. All right, so I'm looking here. A times c, negative 72. Here's what my sum is, that's the 1. So 2 numbers that multiply to negative 72 that add to 1, well, has to be 8 and 9, and the 8 has to be my negative. So multiplies to a negative 72 but adds to 1, we're good. So now I have negative 1 times, in parentheses, x minus 8 times, in parentheses, x plus 9, all equal to 0. So now when I'm solving, right, I can take each factor, set it equal to 0. So if I take here negative 1, make it equal to 0, right, I'm not solving for x, so that's not going to get me a solution for x. And then x minus 8 equals 0, and x plus 9 equals 0. So now from here, I'm just going to add the 8. I get x equals 8. And over here, take away the 9. X equals negative 9. Okay, and those are my 2 solutions. Okay, next up, I'm solving using the quadratic formula. Let me remind you of the quadratic formula again. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this problem, my a value is 1, my b value is negative 2, and my c value is negative 8. So those are the numbers that I'm going to plug in. So here I have x equals negative b. So a negative times a negative will be a positive. So 2 plus or minus the square root of b squared. So negative 2 squared minus 4 times a, which is 1, times c, which is negative 8, all over 2a, 2 times 1. So here's where I start. And now I just have to work to clean that up. So x equals 2 plus or minus the square root. Here I have 4. Whenever I see a mistake, it usually, not always, but usually it happens right in here. It's usually a sign error that occurs. So if I'm multiplying a negative by a positive by a negative, that's going to be a positive. So plus 32 all divided by 2. Okay, clean that up more. I have 2 plus or minus the square root of 36 all divided by 2. Okay, that worked out real nice because that square root of 36 becomes just 6. So I really have 2 plus 6 over 2, and I have 2 minus 6 over 2. So 2 plus 6 is 8, divided by 2 is 4. 2 minus 6 is negative 4, divided by 2 is negative 2. So I have my two solutions. X is 4, x is negative 2. And the fact that those came out real nice as integers clues me in that maybe there was a more efficient way that I could have solved this. I could have solved that by factoring. It would have factored into x minus 4 times x plus 2. So again, I told you to solve it this way, but that doesn't mean that there's not other ways you could solve it. All right, in this next one, here the a value is 1, b is 6, c is negative 4. So x equals, we know it's negative b, so negative 6 plus or minus the square root b squared, so 6 squared, minus 4 times 1 times negative 4, right, 4ac. All divided by 2a, so 2 times 1. Okay, now I'm just working to clean that up. So now I have negative 6 plus or minus the square root. 6 squared is 36. And again, this is where I see any sign error right in there. So I have plus 16, right? Because it's a negative times a positive times a negative. So plus 16 all over 2. So x equals negative 6 plus or minus the square root of 52 divided by 2. Okay, square root of 52, that's 4 times 13, so that's really 2 root 13. So I have negative 6 plus or minus 2 root 13 all over 2. So now I have to think, well, how do I simplify that? Can I simplify that? I can. 2 is a common denominator to the negative 6, and that 2 root 13. So the way that I can reduce, I'm kind of picturing this little triangle, I can reduce if I can see that all 3 of these terms are divisible by the same thing, and they're all divisible by 2. So if I divide each part of this by 2, I end up with negative 3 plus or minus the square root of 13. It would be over 1, and I don't have to write that. Anything over 1 is just itself. So x equals negative 3 plus or minus the square root of 13. Okay, last method is to solve by completing the square. So to solve by completing the square, the whole idea is to create a perfect square trinomial that factors into a binomial squared, so you can solve by taking the square root. But I'll talk you through all of that as we do it. So first thing I do is I want to get the two terms that have an x together on one side. So the quadratic linear term together on one side. Add the 12 to the other side. So x squared minus 8x equals 12. Okay, so now I want to take that linear term, I want to split it in half, and I want to square it. So I'm taking the negative 8 dividing by 2. That splits it in half. That gets me negative 4. And then I raise it to the second power, I square it, and that gets me 16. So now I have on the left-hand side x squared minus 8x plus 16. So I've added 16 on the left. I already had 12 on the right. I can't just add 16 to one side of the equation. I always have to keep it balanced. So I have to add 16 to the right-hand side as well. So now, the whole point of doing that, what's on the link, man, two numbers that multiply to a positive 16 that add to a negative 8, got to be negative 4. It's always going to be half of what that b term coefficient is. So this becomes x minus 4 squared equals 28. And now I can solve by taking the square root. So take the square root of each side. X minus 4 equals plus or minus the square root of 28. That's 4 times 7. So 2 root 7. And then I add the 4 to the other side, and I get that x equals 4 plus or minus 2 square root 7. Okay, next one for b here, I want to get, again, my x terms together, my quadratic linear term together. I'm going to move the 9 to the other side. So add the 9 over. So now I have 4x squared plus 24x equals 9. So now this one's a little bit different. I see that there's a coefficient in front of the x this time that's not 1. So I have to divide that out first. I treat it like it's a common factor. It's not the greatest common factor, but it is a common factor. Okay, so I divided out that 4. Now I have to do that same process of completing the square. I take that linear term, I take that coefficient of 6, I split it in half, that gets me 3. I square it, that gets me 9. So now what I have is I have 4 times x squared plus 6x plus 9, right? That's the new part, equals the 9 that was already there. Now it might look like I'm adding 9 to the left-hand side of my equation, but I'm actually not. I'm actually adding 4 times 9. So since that 4 got divided out initially, remember that if I distributed it back, it would still read as 4x squared plus 24x plus 36. So I'm not just adding 9, I'm adding 4 times 9, I'm adding 36. So now I have 4 times x squared plus 6x plus 9 is a perfect square trinomial. It factors into x plus 3 squared, all equal to 45. Okay, now I need to divide by 4. And then I need to solve by taking the square root. So I have x plus 3 as my quantity squared equals 45 over 4. So if I solve by taking the square root of each side, right here, that splits into the square root of 45 over the square root of 4. Okay, square root of 45 is 9 times 5. So 3 root 5 on top. Square root of 4 is just 2 on the bottom. So let me just clean it up here. Right now I have x plus 3 is equal to plus or minus 3 root 5 over 2. Let me just make a little arrow to here. Okay, so that's where I'm at right now. I know that x plus 3 is equal to plus or minus 3 root 5 divided by 2. Last thing to do is just take away the 3. So x equals negative 3 plus or minus 3 root 5 divided by 2. All right, that's my final answer. Have a good rest of your day.